The developers tried to warn us with the system requirements, showing things like a 7800X3D for 1080p high recommended CPU for the game, and going up to things like a 7900X, RT minimum at 30 frames per second, recommending a Ryzen 5 5600. These are some pretty beefy CPU beefy CPU, I don't even know what I just said. Whatever, you get the idea. Those are a lot of big CPUs, fast, lots of cores, much monies. What's going on here? Also, one of the game developers specifically said, I probably just blinded you with the white background, deal with it anyway, that before the release of Cyberpunk 27 2.0 and Phantom Liberty, please check conditions of your cooling systems in PC. We use all what you have, so workload on CPU, 90% on 8-core is expected. To save your time, please run Cinebench or similar and check stability of your systems. Now, obviously, he's not really saying it'll set your PC on fire unless, I mean, obviously you got something really wrong with your PC setup. It's not the game's fault, but the point is using lots of cores. Now, when the 2.0 update came out, I did a video that was mostly focused on array reconstruction and just general performance in that. However, I did also take a look at CPU limited performance on a Ryzen 5 5600, and I noticed that the patch 2.0 was performing worse than patch 1.63, which I thought was interesting. And again, there was a lot of overhauls to the game's systems. But also we have the, and by the way, the overhauls of the game's systems, AI is a big thing that impacts the CPU. So if your traffic and the police and the NPCs in general have more complicated AI going on, that could be something that is adding to the CPU burden of the game. But now we have the actual Phantom Liberty game out. And remember that this section of the game was not designed with older console generations in mind. So they could be a lot more free with what they're trying to do from like a system requirements perspective. Now, in that video, I was in a video focusing mostly on GPU performance. I was also taking a look at a few different CPUs. And this is the video I released yesterday. And here you see me driving around on like an i5 9600K CPU, and the frame rates are dipping into the low 30s when CPU limited. This is showing GPU busy versus frame time, showing that this is definitely a CPU limited situation. And it's not that it can't achieve good frame rates at times, but driving around in this area was certainly extremely demanding in motion on that i5 9600K. And these were at the game's low settings, which includes turning things like crowd density down and all of that. So then when Phantom Liberty comes out and you see people complaining, I have a RTX 3080 and my performance is bad and DLSS doesn't help. A lot of people don't realize that what they're actually seeing here is a CPU bottleneck. Also, the game has added in an interesting setting here. When I was looking at some of the AMD CPU performance, some people were saying, has he not seen the AMD Simultaneous Multithreading SMT switch that they've added in the game's menu? And I hadn't mentioned that at all, but it is part of the update. All of my testing I was doing previously was leaving that at the auto setting. But in this video, basically yesterday I had some time to pop in some more CPUs, take a look at CPU performance at a variety of settings. One of them is looking at what that SMT setting is actually doing. I'm gonna be tiny and out of the way here. Let's go ahead and roll some footage while I talk here a little bit. So here we're seeing the Ryzen 5 5600X, and I've actually captured some nice side-by-side. Now, the traffic conditions are not identical, but I am doing the same basic run, although occasionally I bump into a bit of traffic. But anyway, there should be some small run-to-run variance, but none of that would explain the 20% performance boost I have for having the SMT on versus off. So if you were wondering, should we turn it off? And by the way, let me back up for a second. Notice that on was the default, okay? So basically, auto was turning SMT on, and it did see a 20% performance improvement compared to turning it off. And you can also see that overall CPU usage is up much higher. We're up in the 80s here, down in the 50% overall CPU usage here. In general, it's using much more of the actual all the cores and threads available. Again, this is a 6-core, 12-thread CPU. But I do want to point out as we're going through here that even with SMT on, which we're only averaging about 60 by the end of this run, but notice that we are at times dipping well below 60 frames per second during this run. And I think that's important to note because you aren't going to be able to lock 60 FPS while driving around without dips on a Ryzen 5 5600X. Now, I was curious, some games have a lot of scalability on the CPU in their graphics settings, and some games don't. So what we're looking at now is on the right-hand side, this is the game running at the low preset, and on the left-hand side here, we're running at the ultra preset. And so we can take a look at the performance differences, and there is a 30% performance boost going down to the low preset versus the ultra preset. But then comes the question, which settings are the biggest, most impactful ones? Because if you are wanting to boost your performance when you are CPU limited, if you're noticing that that's probably your issue. By the way, how do you notice that's your issue? Again, if you're running something like Intel's PresentMon, you can enable GPU busy versus frame time, and if the GPU busy line is below the frame time line, that means the GPU is waiting for something else, and that is a strong indication that you are CPU limited, or at least something else in the system besides your GPU limited. If you're running something more like MSI Afterburner, if you look at the GPU usage percentage, if that is below the upper 90% range, this is an indication that your GPU is waiting around for the rest of the system. And sometimes you can see that all the cores are pretty heavily loaded. And that, again, is an indication that it really is the CPU that you are waiting on. So we're definitely seeing that this is CPU-limited performance. And again, the ultra preset going down to the low preset did get me a 30% performance boost, but also that takes a massive visual hit. So what I wanted to look at next was, is it just the crowd density that's really doing most of the heavy lifting on that? So what we're looking at here is ultra preset on the left, ultra preset with crowd density set to medium in the middle, and ultra preset except crowd density set to low on the right-hand side here. And as you can see, you're getting an 18% performance boost by going to crowd density low. So all of the other settings going from ultra down to low really only accounted for the last 12% performance difference between, remember when we were back on looking at the low preset, right? So the low preset, remember, finished at 79 frames per second, and the ultra preset with crowd density at low finishes at 72 frames per second. So it certainly indicates that crowd density is doing most of the heavy lifting on the CPU burden. However, it is possible, to claw back some more CPU performance from the other settings. It just seems like there's not a lot of bang for the buck on those. And unfortunately, though, setting the crowd density to low does make the city feel a lot more lifeless, which is frustrating. So anyway, that does seem to be the biggest change, though. The other settings that have a big CPU impact are ray tracing. So most people are aware that ray tracing has a huge impact on GPU performance, but it also can have a huge impact on CPU performance, and that's what we're looking at here. On the left-hand side of the screen, we're seeing the normal ultra preset, and on the first we're looking at SMT on versus off. Then I'm going to look at ultra versus RT ultra. Forgot I tested on versus off again. So again, I decided to look at these simultaneous multi-threading. Does it matter on different settings? Like I actually saw a comment saying on one of my videos saying that it helps them when, I can't remember if they said when ray tracing was enabled but not the other way around, or possibly that was flipped. So I thought I'd investigate that. So I checked if ray tracing had a difference on whether SMT was useful or not. So that's what we're looking at here. And with SMT on, which was the auto setting, I was getting 50 frames per second, well, 51 by the end of the benchmark run, and with SMT off, I was at 41 frames per second by the end of this run. And again, while driving, there were certainly dips well below that. But we are once again seeing that the auto setting with SMT on was 24% faster here. So it definitely seems to make sense to have that on, at least on a Ryzen 5 5600X. We are going to look at some other CPUs. But anyway, then I decided to take a look at the RT Overdrive mode. And the RT Overdrive mode was actually performing very similarly. Now, I also want to mention on these ray tracing tests, I am on a 4090, but just to make sure we were CPU limited, I also went to DLSS performance. No frame generation, but this is lowering at a very, learning at a very low internal resolution. So we can see the GPU is not the bottleneck here. This is definitely the CPU limit. And again, RT Overdrive, SMT on versus off, and once again, I'm seeing a performance boost with SMT on. And the overall difference of Ultra preset versus RT Ultra versus RT Overdrive is what we're taking a look at here. And I don't see a lot of difference on the CPU burden between RT Ultra and RT Overdrive. These are coming out basically the same. However, you can tell, and this was my point, that Ultra settings versus ray traced settings, there is a major performance difference, and the CPU is 20% faster, as we can see here at the Ultra preset, versus with the ray tracing presets. So ray tracing does take a big hit to your CPU performance. And then if we jump back to the system requirements chart, which listed a Ryzen 5 5600, now we're testing the X version here, but there's like a 2 or 3% clock speed difference there. It's not a big deal. Anyway, they listed it as ray tracing low. The minimum CPU here for 30 frames per second was the Ryzen 5 5600. Now, one thing you need to understand about system requirements charts like this is they usually go in increments of 30 or 60, meaning if it can't hold a 60 FPS average, then they'll call it 30, even if you'll usually be well above 30, somewhere between 30 and 60. That's generally how system requirements charts should be read, and that is kind of what we're seeing here, right? So the overall average is definitely below 60 frames per second when using ray tracing on this CPU. And we could see as we were cruising through more of the middle of town, we are dipping into the 40s for sure. So this is absolutely not a 60 FPS experience when you're driving through town on this CPU. So anyway, that's my Ryzen 5 5600, but here's where I got interested, because remember the developer tweet saying that they're going to be using 8 cores all the way. Well, I was like, 8 cores? How about 16? Anyway, I don't know why I just made myself bigger. Anyway, so here we're going to be looking at a whole bunch of CPU threads, 32 of them. This is my Ryzen 9 5950X, and I do want to point something out, though, that the test conditions here are not identical to what we saw on the 5600X. So if you're going to compare the performance on that to this versus this to itself, a couple things you should be aware of. This is actually in a different PC. This is in my video capture and editing PC, like it's the one I'm filming on right now. Also, it uses an RTX 4080, whereas my other PC was using a 4090. However, we are CPU limited. My GPU usage percentage, I guess maybe I need to zoom out for you to be able to see that all the way. My GPU usage percentage is certainly low here, and it's still an NVIDIA GPU, which should have similar driver overhead. So it should be similar, like I don't think that GPU change matters too much, but it is a variable confounding the results here, so just be aware of that. Also, because this is my recording editing PC, on the Ryzen 5 5600, I was capturing externally, so there was no video capture happening on the PC that we were testing. Whereas in this footage, because it is my capturing PC, I don't have another PC to capture it with set up. This is recording using NVIDIA's, shadow player, if they still call it that or whatever, basically the GPU capture built into the NVIDIA software. Now, when CPU limited rather than GPU limited, I don't think that's having a major performance difference, but I just want you guys to be aware of that. And the other issue is there's different RAM in the system. Both of them have 32 gigabytes of DDR5 3600 memory. The difference being that this system has tighter timings. This is CL16, and the Ryzen 5 5600 had CL18 RAM, so a bit cheaper RAM, a little bit weaker timings. Anyway, with all of that in mind, is to be aware of the, not in apples to apples if you're jumping between the CPUs, I was more interested in just how does the Ryzen 9 5950X handle the SMT switch? Because this was interesting. Now I'm seeing better performance with SMT off. So SMT on, SMT off, actually slightly better performance, but what I would likely say is this is more like could be run-to-run variance. However, maybe there's a little more to it than that. Because notice that the overall CPU usage goes up with SMT on. Here we're around 50%, which by the way would be fully utilizing 16 threads of a 32-thread CPU. So interesting. Again, this has 16 physical cores and 32 logical threads. Whereas with SMT off, we're down here like in this particular like freeze frame, 38% CPU utilization. But notice that despite the increased CPU utilization, the overall performance is basically the same. So we're going to be adding in more power consumption, more temperatures, more work for the PC without gaining anything from it by turning SMT on. Now this is without ray tracing enabled, and so I had in my head that comment saying that they were seeing a difference on their system whether or not it was ray tracing. So here I dug into that. So this is Ray Tracing Ultra on both sides of the screen, but we're looking at SMT on versus SMT off. And once again, I'm seeing basically identical performance numbers, but with the CPU having to work harder with SMT enabled. Again, we see a higher overall usage, more cores being fully loaded, but for literally no difference in performance, including the 1% lows. They're identical. I also went ahead and tried out the RT Overdrive mode. Now, once again, I'm using DLSS performance when I'm in the RT modes, even though that wasn't written on the screen, but I want to say that to make sure you guys are aware. Again, DLSS performance is making it so we are still CPU limited despite being on such a GPU heavy workload like the RT Overdrive mode. Anyway, here, once again, we're seeing a basically identical performance, and if there is a difference, it's slightly in favor of SMT off. So what do I make of this? Well, what I mostly make of it, before we jump to the next CPU, is my guess is that the game can't really utilize more than 16 threads. So with SMT off, this CPU is going to be using its physical cores, and it has 16 of them. So if the game can basically stop scaling beyond 16 threads, and this CPU already has 16 physical cores, then enabling the multi-threading to the logical cores doesn't benefit it, because now while you get 16 additional threads, they aren't actually helping the game perform any better. I'm not an expert on parallel processing, but I think with games, there's an issue where one reason why they're so hard to parallelize is eventually all of the stuff that you're splitting off into separate threads does need to tie back together to actually be in like the game's main thread, the main, the performance of the game. And the more you split things off, I think the more difficult it is to tie it back together in the end. And so I think there's at a certain point kind of a diminishing return to splitting it all up if you have to put it all back together again. If that makes any sense. I'm also not a game developer or a programming expert, so maybe I could be misunderstanding the situation, but that's my understanding of it. So basically it looked like the game could not really take advantage of more than 16 threads. Anyway, I also decided to test out my Ryzen 7 7800X3D. Now this one is again on a different system. This has 32 gigabytes of DDR5 6000 CL30 memory, and I'm back to capturing externally, and we're using the RTX 4090 as the GPU, but again, we are CPU limited. Here we're looking at the 1080p Ultra, and we're actually able to get good frame rates here, and we're looking at SMT on versus SMT off, and this time we actually are seeing an 18% performance boost for SMT on. So again, this is an 8-core, 16-thread CPU. So again, by turning SMT on, it's allowing it to go, to use those extra threads, whereas with SMT off, it was not, it was more, I think the game tries to be more limited to the physical cores, is I think what's going on there. So again, what we're seeing here is that there is a benefit for an 8-core processor to then enable those extra threads. Here I'm looking at RT Ultra again, and we definitely see a performance drop compared to our just normal Ultra preset. However, SMT is still showing a benefit, and it's still an 18% benefit. So definitely seems like it makes sense to have that on. And by the way, it did default to on when we were at the auto setting. So taking a look at that here. Also, I did once again test out the RT Overdrive mode. And once again, this showed similar CPU utilization, although if we hop back to RT Ultra, where's RT Ultra here? 97 and 82, and now we're down to 91 and 77. So this is showing the RT Overdrive mode taking a little bit of a lower performance average than we saw on RT Ultra, even when CPU limited. Whereas on my Ryzen 5 5600X, it seemed like there wasn't too much of a difference between the two. So I thought I'd point that out. But once again, we are seeing that the SMT button on does seem to be helping. So anyway, I think that's the tests that I had time to run for this video. What's my overall conclusion? The game's system requirements that were updated for Phantom Liberty with extreme CPU requirements, especially to hit 60 FPS with ray tracing enabled, actually seem like no joke. Now, I don't really benchmark CPUs on my channel. I'm really more GPU and then just like hardware news focused. And I like to test how games perform, but basically I don't have a whole bunch of CPUs, so this is the extent of what I could test. I don't have a bunch of Intel CPUs, especially not high-end ones, to compare relatively here. Again, the only Intel CPU I had was the i5-9600K that I did take a look at in my last video, and we did see that struggling even at the low preset, which we did see gave a big performance boost going down to low versus ultra. So that's the extent of what I can test for you guys, but it certainly seems like no joke that the game is CPU limited. So keep in mind, if you're not getting good performance since the 2.0 update or Phantom Liberty, especially in the Phantom Liberty area of the game, there's a good chance to look into whether it is a CPU limited issue. If you're CPU limited, then like using something like DLSS to lower the rendering resolution, if we're not talking about frame generation, won't be boosting your frame rate by much, if any, again, because of the CPU limit that's happening there. That's reducing the burden on the GPU, not the CPU. Same thing with FSR, that kind of thing. So just be mindful of that. And if you are CPU limited, like I said, it seemed like the crowd density settings were the biggest impact I could find for the CPU performance, but it did look like there was some other stuff on offer with the other settings when we just compared to everything at low. All right, I think that's what I've got for you today. Also, if you come down to the question about the SMT button and should we be using this. Again, the game defaulted it to being on auto, and it seemed like auto was selecting on, and that did seem to help. The only CPU where it seemed questionable was if we had more than 16 threads, right? The 5950X. So maybe in that situation, you might want to play around with it, or maybe other CPUs would respond differently, I don't know. And also, again, this is an AMD setting, not an Intel setting. So if you're on an Intel and you're like, I don't have that button, well, that's why. Anyway, all right, that's what I've got for you guys today. Hopefully you found this useful and or interesting, but again, looks like my other video looking at a lot of GPU performance. Keep in mind, if you are CPU limited, that could be why you can't get a high refresh rate here. And I hope all of you have an excellent day.